All right, good morning again, Honors Integrated 2. So today we are solving nonlinear systems. Well, so you might be wondering if it's nonlinear, what was linear systems? Well, here's an example in red of what linear systems were. Linear systems are when you have two lines, straight lines, hence the word linear, and they cross at a specific point. And only one point. So where these two straight lines cross, boom, is the solution X and Y. You might recall you had to solve this by graphing like this, by substitution, and also by elimination. We have actually done all of that in our class. But this is called linear because we have two straight lines. Well, then what's nonlinear, right? Well, I mean, if it's non-straight lines, well, at least one of them has to not be a straight line, but one of them is a straight line. So you do have a straight line, but then we have a parabola. And of course, what does this bring up? This brings up the idea that it can intersect in two spots. And so that's the kind of the difference between a linear and a nonlinear. In a linear, they're only going to cross one time, and that's your one solution. In a nonlinear system, they can cross twice. And that's where we're going to find the solutions, right here and right here. By the way, what are the solutions? The solutions are the x values. The x values of where they cross. So whatever this x value is here, and whatever that x value is right there, those are our solutions. So let me show you a little bit more about this, all right? Okay, so when you solve nonlinear systems of this variety, there are three possible solutions that you can come up with. The first one is you can find two solutions, and of course, that's because this straight line will intersect that parabola in two spots. It'd be here and here. So we'd find our two solutions. Remember, what we're finding is the x value, whatever that is, I'll call that x1. And then this one right here, I could call that x2. These would be the two solutions that I'm looking for. You could also have one solution, and that's where a horizontal line just barely touches the vertex of the parabola. In that case, it would only be one solution, and we'd be looking for the x value of that point. Remember, it's going to have an x and a y for sure, but our solutions are the x. But then, of course, we can also have no solution. And no solution is when the straight line and the parabola don't intersect at all. And there's a lot of ways for that to happen. So these are your three possibilities here. You can have two solutions, one solution, or no solution. Why don't you pause this video and copy that down. All right, so when we're solving these, we are going to use two approaches to solving these. One is graphically, and I'm going to let you off the hook pretty easily with this stuff. If we were in class, I'd be giving you graph paper, and we'd be doing this with rulers and stuff, but instead, we're just going to use Desmos, and you guys are pretty familiar with Desmos. All you got to do, this is pretty simple, is graph the two functions on Desmos and find the points where they cross. So pretty simple. So you're going to graph, then find the points of intersection and list them. And that is going to be your solution of intersection. So that's what we're doing today. So today's kind of easy, not that hard. Tomorrow gets a little bit more complex because we can also do this algebraically. And when we say algebraically, we're talking about using algebra. And that's when it starts getting a little more complicated. This can bring in problems that have quadratic formula and factoring and stuff like that. So this, I'm going to put out a video on either tomorrow. I think it's going to be tomorrow, actually. And then we'll do a little bit of work on that tomorrow. But today, we're going to solve them graphically using Desmos. Not that complicated. Plug it into Desmos, find the points of intersection. Those points of intersection are your answers. Let me show you an example real quick of what that might look like. Okay, so here's an example of a nonlinear system. Here we have two functions, y equals x squared minus 2. That's a parabola. That's the parent graph shifted down twice. And then I've got the linear term y equals x. Y equals x where I have to connect that. We'll take a look at it. This is y equals x plus 0 with a slope of 1. So I'd start here. I'd go up 1 over 1 there, up 1 over 1 there, and I'd connect this. Let's see. So like this. And it's supposed to be crossing here and here. So how many solutions do we have? Well, clearly we have 2 right there, right in there, right? What's the ordered pair of this one? That is -1 and -1. What's the ordered pair of this one? It's 2 and 2, like this. Boom. Here are my 2 solutions. Now the x values here would be -1 and +2, and I said these are the solutions, and it's true. That's because when you plug this in, it works for both of them. But let's put the entire ordered pair there as the 2 solutions. So here's a solution, there's the solution of the nonlinear system. You're going to do this in Desmos, going to be pretty simple for you. But I want to talk real quick about a word problem. All right, now this example is in your book. We're in 9.5, and look here, it's a rock climber, right? He's got his pack, 175 feet tall. Let's see, he's pulling it up at 2 feet per second. He's pulling a pack up the hill, or up the rock. There's that. Climber drops a coil of rope, and let's see, from above the pack, the height of the coil is this. At what time does the coil of rope hit the pack? So you have a pack going up and some rope going down. When will they meet? And listen, this is not all that complicated, especially if you're using Desmos. Look, here's one function, here's the other function. They give you the functions. Simply plug them in to Desmos and solve like this. Here, watch, you can see they did that right there, and then they can even just click on it in Desmos and find where do these points cross. And the 2 points, it's tough to see there, but it's -3.375, -6.75, and this one as well, 3.25 and 6.5. One thing here is it does say the x value represents time, so this solution is not reasonable, and that's because you can't have a negative time. You're going to be doing a couple problems like this today, and just use Desmos, okay? I think you got this. All right. Once again, I hope everybody's doing well, and I'll talk to you soon. Text me with questions, all right? See ya.